Wouldn't it be nice if you could download a dataset from Kaggle and be able to run a bunch of machine learning algorithms on it right away? Wouldn't it also be nice if by simply pressing a button you could also see a meaningful distribution of that data? Well, that's exactly what ML for Dummies version 1 intends to do. So the first thing that you want to do is take a look at your dataset and figure out what exactly is it that you want to predict. So as you can see, I selected product role as my target class, meaning that I want to predict the contents of this column. Then we also have this entry called null percentage at which columns are dropped. So this is pretty self-explanatory. Let's take a look at this column called age at adverse event. As you can see, it has quite a lot of missing values. So if I enter 67% here, it means if age at adverse event column has more than 67% of its values missing, then it will automatically be dropped. Next, as you all know, machine learning algorithms can only work with numerical data, such as the column here and the one here. The rest, all of these are categorical in nature and hence they have to be encoded. So there are two ways you can go on doing this. You can either label encode them or one-hot encode them. So label encoding is pretty self-explanatory. Suppose you have this column called body style. It's going to assign a number to each of these unique attributes in this column. So suppose it will give convertible a value of 0, hardtop 1, and so on. So as you can see, after label encoding body style, convertible has been turned into 0, hatchback to 2, and sedan to 3, and so on. But there's a catch here. While it's pretty straightforward, machine learning algorithms can be misinterpreted by numerical values. Suppose the value of 0 is obviously less than the value of 4, but does that really correspond to the dataset in real life? Of course not. So that is why we have one-hot encoding. So with one-hot encoding, you see each of the unique attributes in a column will be turned into separate columns. So suppose you have here rear-wheel drive, forward-wheel drive, and four-wheel drive. So if you were to label encode drive wheels, you'll have 3 separate columns for forward-wheel drive, four-wheel drive, and so on, whatever. So that's how it works. So if you want further clarification, suppose at row 1 you have drive wheels as rear wheel drive. So if we take a row 0, you have 1 at rear wheel drive and the rest zeros. So that's how one-hot encoding works. So basically, if a column has more than 2 unique attributes here, it will one-hot encode them, otherwise it will label encode them. Now if you were to enter 0, none of the columns would be one-hot encoded. Now next we have what is called perform cross-validation. So as you know, what cross-validation does is if you select k to be 10, it will create 10 different variations of the data set with the training and testing data varying in each of them. So if we have cross-validation on and you select an algorithm and run it, it will basically run that algorithm 10 times on 10 different versions of the data set. So you can see this will obviously return more reliable results. Now skipping to this next 3 features, let's take a look at the data summary. So as you can see the total column and row count here, as well as the total number of null rows. Next, you can also get an in-depth look at each of the columns, like their null percentage and how many unique values they contain. So as you can see, 6 has about 59% missing values, and there are 4 types. Now if you're wondering what those 4 types are, let's take a look. So it's female, male, inner, and null, which is not shown here obviously. So you can also plot a bar chart or a histogram depending on whether the column that you've picked is categorical or numerical in nature. If it's categorical, you'll get a bar chart. If it's numerical, you'll get a histogram. Suppose age at adverse event was numerical, so you'll get a histogram in this case. Now you can also find out linear relationships between two columns. Now since there is one numeric column in our data set, I can't quite show you this. But maybe I'll show you this in a different data set. So you can also select to drop columns manually, because sometimes you'll have absolutely useless columns in a data set. Suppose report number here. It will only confuse an algorithm and have no use for it whatsoever. So you can drop columns such as this. So you can also export an encoded version of the file that you uploaded. So all you have to do is press export CSV. As you can see, a new file has been generated. And since we had 0 in this label encode field, all of the categorical columns have been label encoded, as you can see. So that's export CSV in a nutshell. So another thing that I've added is called the feature selector. As you can see, there are a bunch of options that you can pick from to find out which feature is the most important. So if we use feature importance here, which uses an extra tree classifier in my code, you can see the results, which I've chosen to not show in this window since it would clutter it, and instead chosen to show here in this console. So if we press generate, as you can see, we've already have the results. So according to extra tree classifier, reported product name is the most important, followed by one row coded symptoms. And lastly, I have this thing called try every possible feature combination, which does exactly what it says. It tries every possible feature combination and runs the algorithm on each of those combinations. So if you want to see a demo, here it is. So as you can see, the best score that we've gotten is 67.27% from this columns. So as you can imagine, it will take quite a while to finish trying every possible features from how many? I don't know how many columns we have right now, but whatever that number is, it's pretty big. So that was ML for Dummies in a nutshell. I plan to add a few more features such as ROC curves and hyperparameter tuning. So thank you for watching.